Okay, so in this video, we are going to look at how do we do what is called implicit differentiation. So most of the time, we have y defined explicitly as a function of x. So maybe something like x squared plus 5x. That we have y is defined explicitly in terms of x. But there are going to be times when we have y implicitly defined in terms of x. So it might be something like this: x squared y minus 2xy plus y squared equals 4. Now, when we have something like this, there's no way to get y in terms of x. But we still might want to know what is the derivative. We might want to know how fast does y change as x changes. And so when we have something like this, we utilize what is called implicit differentiation. Now, the key to implicit differentiation is to assume that y is a function of x, and so we must use the chain rule. All right, so anytime we see y, we're going to assume that y is a function of x. So y equals some function of x. All right, so that's kind of the key here, is making sure that you assume that. All right, so when we go to here, what we're basically doing is we're going to, this is a function. You can consider this to be a function, and this is a function. So you will note I'm going to have to do a product rule here. But then when I take the derivative of that, I have to consider that y is a function of x. So what I'm going to have here is I'm going to use the product rule. So we're going to have 2x times y. So that's the derivative of the first times the second, plus, now I'm going to do the first times the derivative of the second. Now, the easiest way to do this is to just write it as y prime. All right, minus, now, again, I have to do the product rule because you will note here I have a function times another function. So I've got to do the product rule. So what I need to do is, since the product rule has the sum of two different pieces to it, I'm going to put this in parentheses. The derivative of the first is going to be 2 times the second plus the derivative of the second times the first, so 2x y prime. All right, now plus, now this one's interesting because what we want to consider here, considering this, is we want to think of this as y squared. And remember, that's a function of x. So what we're going to have here is 2 times y, right? And you could say to the first, times what the derivative of what's inside, which is y prime. And this is an example of where we're treating y as a function of x. We just don't know what function it is, all right? So you can kind of think of that as that it is a function of x, but it's just unknown at the moment, okay? And then the derivative of 4 is just 0. Now, at this point, the rest of this is just algebra. What we're going to do is we're going to factor out every term that has a y prime. So notice this term has a y prime in it, this term has a y prime in it, and this one does. Okay, so each one of those has a y prime. So I'm going to have y prime times, this one has an x squared, this one has a minus 2x because of that negative, and this one has a plus 2y. So that's all the terms with y prime, and every other term is going to go to the other side. So this one moves to the other side, so that's minus 2xy. This one moves to the other side, that's plus 2y. And those are the only other terms. So now I divide over and I get that y prime equals negative 2xy plus 2y over x squared minus 2x plus 2y. Now, if you could, notice I could factor out a 2y in the numerator, but I can't do that in the denominator, so there's no need to simplify this. This would be our answer here. Okay, so what I'm going to do is I'm going to give you another example, and I want you to try it. Pause the video and try it after I write this down. So let's try this one here. 3xy minus 2x squared y plus 2xy squared equals x plus y. All right, so pause the video and try that one. All right, so when we do one like this, we have, again, a product rule. So you'll notice I have two functions. I'm going to treat y as a function of x, and so I'm going to have the derivative of the first, 3 times the second, plus the first times the derivative of the second, y prime, minus, now I'm going to use parentheses here. I've got another product rule. Derivative of the first is going to be 4x times the second, plus the first 2x squared y prime, plus derivative of the first is 2 times the second, plus, now the first times the derivative of the second. Now what we're going to do is, remember on this one here, we're going to consider this to be y squared. So we're going to use the power rule here. So we're going to have 2 times y prime equal to, now over here that would be 1 plus y prime. Now this one's a little different than the previous one because I have y primes on both sides. So I'm going to gather all the y primes on the left. I've got one right here, I've got one here, I've got one here, and I've got one here. So we're going to put all those on the left side. So I'm going to have y prime, I've got a 3x, I have a negative 2x squared, I have a positive, notice this is going to be 4xy, and then this one, when I move it over, is going to have a minus 1, right? Because when I move it over, it's negative y prime. And everything else is going to go on the other side. So I've got this negative 3y, I've got this positive 4xy, I've got a negative 2y squared, and then I have this 1. So now I divide over and I get y prime equals negative 3y plus 4xy minus 2y squared plus 1 all over 3x minus 2x squared plus 4xy minus 1. Now I do want to note something here real quickly, that if instead of moving all the y primes to the left, you moved them to the right, which is, by the way, fine to do that, then you would have had the exact same answer, except every sign would be the opposite. But that's like multiplying by -1 over -1, and so you get the same answer. Okay, let's try one more that I want to show you that's a little bit different. Suppose that we had something like this, x e to the y sine of x equal, we'll say y. Okay, so this one's built somewhat the same. Notice right here I have a function times another function, but this function here is going to be requiring the chain rule because this is e to a function here. So, all right, so we'll take the derivative of the first, which is 1, times the second, plus the first times the derivative of the second. So this is where I'm going to do e to the y sine of x, and then I've got to multiply by the derivative of this. Now, we really want to see this as a product, right? This is a product here. And so I'm going to do the derivative of the first, y prime sine of x, plus, now the derivative of sine is cosine, so I'm going to have y cosine of x equal to y prime. So notice what happened here. I had to use the chain rule to get the derivative of e to that. Now, once again, we want to get all our y primes. Now, notice I have a y prime right here and one there. Okay. So on this one, I might move this over to that side instead and leave everything else here. So here I have e to the y sine of x. And notice I've got to multiply this through. Okay, so when I do that, this becomes plus x y cosine of x e to the y sine of x. So I'm just multiplying all this times all that. And none of those have y prime. Now this one, when I multiply it, it has a y prime in it. So I'm going to move it to the other side. So I'm going to have y prime minus, and this is going to be multiplied by there. So it'll be y prime, xy prime, sorry, sine of x e to the y sine of x. Now I factor out the y prime here, and I get 1 minus x sine of x e to the y sine of x. And so then I can say that y prime equals this e to the y sine of x plus xy cosine of x e to the y sine of x all over 1 minus x sine of x e to the y sine of x. So it's a bit of a, algebra exercise, or algebraic exercise right here once you get past there. But again, the key with implicit is to make sure that you consider treat y as a function of x. And so every time you have to take the derivative of y, you're going to say that that's y prime.